guys, welcome to VChem World. Today we will discuss on the crystal lattice. In crystalline solids, definite orderly arrangement of the particle in three dimensions. All particles like constituent particles, atom, ion or molecule are relative to one another. For example, this is the atom. This arrangement is regularly. This is known as the crystalline solids. But on the definition of the crystal lattice, the arrangement of infinite set of point. This is known as the point. In the crystalline solids, we use as the constituent particle, but in the lattice, we use as the point. So this total arrangement is known as the space lattice. And it's one particle, it's known as the lattice point. Its definition, the positions which are occupied by the constituent particle. This position occupied by the constituent particle. Constituent particles like atom. So this is known as the lattice point. This is the lattice point. Next, lattice is the one-dimensional, two-dimensional and three-dimensional. But in the physics, 4 dimension present. 0 dimension, 1 dimension, 2 dimension and 3 dimension. In the 0 dimension, only 1 point present. 1 dimension, constituent particle present in only row. 2 dimension means particle present in the row and column. This is the 2 dimension. 2 dimension means plane present. 2 dimension lattice. 2 dimension means constituent particle present in row and column. This is the 2 dimension lattice. In the 2 dimension lattice, a regular arrangement of the constituent particle in a plane. This is the, for example, this is the one constituent particle, atom. This gives the plane. So this is the 2 dimension lattice. This lattice divided into 5 parts. There are 5 types of lattice. Square lattice, hexagonal lattice, rhombic lattice, rectangular lattice and parallelogram lattice. On the basis of this lattice is defining different between the symmetry. In the hexagonal is the more symmetric than the other and parallelogram is the less symmetric than other because of its arrangement in this space lattice. For example, this is the lattice point. How to arrange this space lattice and give the shape. For example, these 4 constituent particles are selected and this joined by the edges. It gives the square lattice. When another space lattice, this is the rectangular space lattice. So different arrangement of this space lattice by connect with edges, it gives the different space lattice. 4 point 1, 2, 3, 4 and connect them, it gives the square structure and it's known as the square lattice. But when this square lattice connect with the other edges, it gives more square lattice and complete the lattice structure. This one square lattice is known as the unit cell. One unit cell gives the information of the entire crystal. So this smallest part of the lattice it's known as the unit cell and this whole part is known as the 2-dimensional square lattice. Next we discuss rhombic lattice. It is the unit cell is the rectangular. So when interior point in the rectangular unit cell or interior point present in the unit cell, this is known as the centered unit cell. and interior point is absent in the unit cell is known as the primitive unit cell. So this type of the unit cell is known as the centered unit cell, and this type of unit cell known as the primitive unit cell. Then next we discuss on the two-dimensional lattice and its unit cell. Two-dimensional lattice and its unit cell. Unit cell means the smallest part of the lattice, and lattice means the all unit cell combined with give the one structure. It's known as the lattice. Unit cell give the information of the entire lattice. First, square lattice, its unit cell square. Rectangular lattice, its unit cell rectangle. Parallelogram lattice, its unit cell parallelogram. Then rhombic lattice, its unit cell rectangular but with interior point. Rhombic sulfur with interior point. In previous we discussed interior point present means centered lattice and interior point absent means primitive cell. Fifth, hexagonal lattice. Hexa means 6. Rhombus with an angle 60 degree. Rhombus with an angle 60 degree. This is known as the hexagonal lattice. So this is all about the two-dimensional lattice. Thank you.